For these last two problems, we're going to look at how the limits affect the shape of the graph. We're going to try to put together all the things we learned in section 3.3 with the new things we've learned in section 3.4. And so in 3.3, we talked about how derivatives affect the shape of the graph, and what was important is that when the derivative was positive, that meant it was increasing, and when the derivative was negative, that meant it was decreasing. The second derivatives now affect when the graph is concave up and concave down. And then what's more, and then now what we talked about is the limits, and so limits tell us about an asymptote. So now we can start to get even a better picture of the graph because we don't just know when it's going up and going down, we kind of know what the end shape of the behavior is, so the end behavior of the graph. So now let's take these things and try to put them together to make sense of a graph. So first thing we're going to notice is that it's increasing when it's less than -1 and decreasing when it's greater than -1. So I'm going to put -1 here. I'm going to put kind of myself a dotted line here. And I'm going to notice that it's increasing here and decreasing here. So that means we kind of know our graph goes up and then back down. But we're not completely sure what it's going to look like after and around that. Well, we know at +1 is where it switches from concave up down to concave up. So when we are greater than 1, we're concave up over here. When we're less than 1, we're concave down. So that means that our graph kind of has a downward shape all through here and then an upward shape right here. Oh, and then then we know we have an asymptote at x equals 2. And actually, I feel like I graphed this too big. I feel like I need to change my scale a little bit. The reason why I think I need to change my scale is you'll see that I have 2 for an asymptote. 1, 2. I have 2 for an asymptote, but it's going to be decreasing towards 2. I had 2 at the very top. It would be hard for me to come up and decrease. So I'm going to make it where I can approach 2. And we'll put 1 here, -1, 1, 2, 3, 4, 5. Okay, those numbers don't matter so much. 2 is the only number that really matters. So I'm going to make myself a horizontal asymptote at 2. So that means as I go towards infinity, I'm going to be approaching kind of this asymptote here. As I go towards -infinity, I'm going to be going down that direction. Oh, as I go towards -infinity, I'm going to be going towards -infinity here. So now I can start to put all this together. My goal is to vision all these things into one graph. And so my graph is going to be increasing here, decreasing here, and then decreasing here, and then we level off. So I'm going to increase in a concave down kind of way. So, and then we'll have a maximum here where we switch from increasing to decreasing. So it looks something like that and something like that. Let's make this a little bit more gradual. Okay. And then we're coming down here, but then what happens at this point? This point is where I switch to concave up. So I've got concave up, and then here I've got concave down. And then if I did it right, I hit my maximum right here, and I come back down here. So increasing, decreasing, concave down for all of this section, concave up right here, and the asymptote right there. Okay, let's now go to this last problem, which is where we think about, where we kind of take this problem that we did, which was x squared divided by x squared plus 1. And earlier, we'd switched it into concave down, concave up, increasing and decreasing. So we kind of made sense of it, and we had this shape, but we said we're not really sure what happens on the ends. Let's now look at what happens on the ends and see if we can take that and make that into a little bit better picture. So what happens at the ends? Well, that's what happens when we take the limit as x goes to infinity of x squared over x squared plus 1. Now this one isn't so bad because we can look at it. It's really quick. This one we have degree equal to 1. And this one we also have degree equal to 1. So all I have to do is compare their coefficients, which are both equal to 1. So this limit is 1 over 1, which is equal to 1. By the way, we could also think about -infinity, but since these are squared, negative numbers do the exact same thing as positive numbers, so we still get a positive 1. So this means that if I come over to my graph, what I actually have is a horizontal asymptote at x equals 1. So if I put, say, 1 right here, then what I really have is a horizontal asymptote here. So that means this graph looks basically the same, except as it comes, it levels off and levels towards that point. So we've got that it's concave up and then concave down, and it flattens towards that point. So concave up, concave down, and flattens towards that point. So we have the same shape, but now we kind of know what's happening on the endpoints. The endpoints are approaching that value of 2. Okay, putting all these things together is the big idea of section 3.5. And I would encourage you to spend a little bit of time looking at 3.5, but we're going to skip that. I'm not going to make a 3.5 video or ask for 3.5 homework. And the reason is, by the way, 3.5 is a great section, but what it's doing is it's kind of rehashing all these things we've learned and putting them all together. And I feel like for the sake of time, we need to go ahead and move on to the next section. But good luck as you study these things. And the next section is 3.7, and that is going to have some word problems for us. And that'll be the last section before our take-home quiz. So good luck studying and preparing, and I'll see you soon.